Jose?
Look at the y-intercept.
You looked at the y-intercept. Okay, so where did you look exactly to find that on your graph?
I looked at the equation -7, and then I looked on the y-axis for -7.
Okay, so we can look on the y-axis. If you didn't have this written down, or if you didn't do this as your second step, make sure you follow along. So I'm going to look here on my y-axis for -7, right? I see this one has a -7. I see this one has a -7 as its y-intercept. So now I have two options. How do I narrow it down from here? How do I narrow it down from here? Because here I see they both have a negative slope. They both have -7 as a y-intercept. So then how come the answer is J and not G? Alright, so I'm going to ask Jose to share. As he's sharing, make sure you're tracking him and listening to what he said and comparing it to your own logic that you thought. Go for it, Jose.
The slope is -1x. So it goes down 1 over 1. Or you can just go from the slope up 1 over 1 to the left and see if it's on the line, and then keep going up 1 over 1 to the left and see if the slope is continuous throughout the line.
Okay, so you could find the slope, but here it's really hard because I don't have a grid on here and it's hard to find the points. So how can I check the slope without trying to plot them specifically? How else can I tell from the slope of this line that if, for example, this one, it might not be -1 over 1? How can I see that it's not -1 over 1? Edwin? The steepness of the line? Okay, so can you explain a little bit more? Okay, so I agree. We talked about this before. The steepness of our slope, the steeper it is, the larger it'll be. But I still don't know what the magnitude is, so can I really compare them like that, Edwin? No, but here's something you could do, right? If I'm looking at this, I notice I don't know this point exactly, right? But it's something less than 2, right? If I actually tried to estimate this point from -7, so I'm going 7, right? Yeah, I'm going 7 up, and then over something that's less than 2. But I know my slope should be 1 over 1. So the ratio should be what, everybody? My ratio of my y over my x should be what? Turn to your table groups. Take 30 seconds to discuss what should my ratio look like for my change in my y over my change in my x. Go. Alright, so bring it back in 5, voices off in 4, eyes up here in 3, 2, 1. All eyes up here. Let's discuss. So, what should my ratio be of my change in y over my change in x? Right, well, first of all, what is this ratio? What's the name that we have for this ratio? What's the name we have for this ratio? Adam? What do we call this? The rate of change, right? Okay. I know my rate of change is equal to what, Patrick? Huh? What is my rate of change for this function going to be? -7? Okay, can you, whoa. You got your answer. Be confident in it. What should the rate of change be for my function? 7. -7. -7 was our what that we discussed here? So what is my -7, Patrick? The y-intercept, but I'm looking for my rate of change. So, Patrick, I'm going to ask this again. What is the rate of change for my function? What's the rate of change? Can you call on someone else to help you out? Okay, voice is off. Voice is off. I was asking Patrick, right? And then I asked Patrick to ask somebody else. That means that we're not turning to Patrick and we're saying, hey man, this is the answer, right? Because he's actually going to ask somebody else. So, Patrick, why don't you ask someone to help you out? Who can help Patrick out? What is it for a rate of change? Come on, someone, Patrick. Ask them. There you go, Arla. It's -1. Snaps if you said it's -1. Alright, so you got it, Patrick. You knew her name. So it should be -1, but I can see this ratio here does not look like it's -1/1. It looks really unequal, because if you look, if this is 7 and this is less than 2, and this is something, maybe it's like 1 or 1.7, that's not going to give me a ratio of 1/1. So that's another way that we could actually eliminate that option and get that the answer would be J. That one is a little bit tricky, right? That one's a little bit tricky. Okay, so here's what I want you to do. So we're not going to go through any more of them. If you have questions about the big rocks, you make sure you can come to my ops hours. They're on. When are my ops hours? Who knows?
Wednesday, Thursday.
There we go. I didn't put them on my door since yesterday we didn't know. But you come to my ops hours and you can double check. Now, here's a question. Raise your hand if you got 3 out of 5. I didn't ask for Thomas. Just raise your hand if you got 3 out of 5. Raise your hand if you got at least 3 out of 5. Raise your hand if you got at least 3 out of 5. Raise your hand if you got at least 4 out of 5. Raise your hand if you got at least 5 out of 5. Snap it up. All right, so real quick, raise your hand if this was your highest score on your big rock so far. No, okay, let me snap it up for me. Raise your hand if you've grown on your big rocks from when we started with our first one to this one now. Raise your hand if you've grown from when we started to now. A couple of people, where you've seen the trend of going up. All right, so snap. What we're looking for in big rocks is that we're growing, right? So if you do have those specific questions about your big rock, make sure that you're asking them. You can come to my ops hours to double check. Cool? So here's what I need you to do. Go ahead, put your pink tracker away, and pass your big rock pieces of paper forward. Do this silently. Voices off. Passing them forward in 15, 14, 13, 12, 11, 10, 9, 8, 7, 5, 4, 3, 2, 1. All right. So raise your hand if you have your graphing calculator today. Awesome. A lot of us. That's okay. I didn't have it, but I'll let you borrow mine. So, here's what's happening. I'm hearing a lot of side conversation. So, we have so much to get through today. And today we're transitioning from what we've been talking about in the past, linear functions, lines, segments, to a new topic, quadratics. Okay? And you may have heard about quadratics in the past. But today we're going to make sure that the important information about quadratic functions are in the front of our minds so that we can move forward and use what we know about lines, line segments, midpoints, and all of those things to move forward and relate them to these things we're going to talk about that are called quadratic functions. So, this is why it's important that you have your graphing calculator. Today we're going to look at a couple of quadratic graphs. So here's what I need you to do. If you do not have a graphing calculator, make sure that you're looking over at somebody else's, but they're going to input a couple of quadratic graphs into their calculator. And here are the functions that you need to put in. So here I have a list. Libby, Amanda. we do not need to be switching calculators yet. Just go ahead and wait for the end of my instructions. So, here we have a couple of functions. So everyone should be looking forward, tracking me. I'll eyes up here. Do you have a question? Is this the classwork you're asking for? So, we don't need this right now. I'm actually going to go ahead and we're going to walk through this as a group. Okay? So here's what I'm going to do. We're going to look at only a couple of these functions.